Okay, so let's carry on with our examples of proving trig identities. So we're going to increase the level of difficulty and try to bring in some other techniques. All right, so a first example on this one. Let's take cos squared x minus sine squared x all over cos squared x plus sine x cos x, and that's supposed to equal 1 minus tan x. All right, so the first thing we need to do is establish which side we want to work with. In looking at this, to me, the left side is the messier side. So we want to start with that. So again, write down left side equals, make no changes here. So write down exactly what's there. So tell the person reading your proof what you are working with. All right, now in this one, totally different than other examples that I have put up. Okay, we're going to use some new techniques. And this is where I told you need to remember some of the concepts that you learned in previous years. And in this one in particular, what we want to do is we are going to factor. All right, so you learned how to find common factors, you learned how to factor the difference of squares, you learned how to factor simple and complex trinomials. On the top, in the numerator position, this is a difference of squares. You have a squared term minus another squared term. And what you found when you did this, when you factor the difference of squares, you get the product of two binomials. In the first position of each bracket goes the square root of the first term. Square root of cos squared x is simply cos x, so put that in the front of each bracket. What goes in the back of each bracket is the square root of the second term. Square root of sine squared x is sine x. So put that in the back of both brackets. And then we saw that what we have in one bracket is a plus sign, and between those two terms in the second bracket, a minus sign. Doesn't matter which bracket you put the plus or the minus sign, as long as they're opposites. Down in the bottom, in the denominator position, we're going to factor as well, but it's not a difference of squares. Okay, first thing, even though there's two terms, that's a plus sign. Okay, for a difference of squares, it has to be a minus sign. This is a common factor. I have a cos squared x here, and I have a cos x there. We can factor one out of each of them. So you put that down in front, and then you simply divide this amount out of each of these terms. Cos squared x divided by cos x will leave you with one of them. Put the plus sign down. If you were to remove the cos x from this expression, you are left with the sine x. Now I know that when you look inside these brackets, there's lots of stuff going on, but what you need to remember is this is just a number. So is that a number. So is this a number. So is that a number. So you have all multiplying and dividing going on. When you have something in the numerator position that is exactly the same as in the denominator, they wipe each other out. Okay, if this was the number 3, if you multiply by 3 and then you turn around and divide by 3, all you have is 1. Okay, they've taken each other away. Okay, the next thing that I'm going to do is I have this left is cos x minus sine x all over cos x. When you have a single term in the denominator, and you can only do this when it's a single term, you can separate these two. So in other words, I can take the cos x and put it over the denominator, put your subtraction sign down, and then write the sine x over the cos x. And the reason I'm doing this is, remember I told you, even though you're working with the left side, don't go and ignore the right side. I eventually want to get to 1 minus tan x. Well, we learned early on in math that anything divided by itself is 1, so it doesn't matter what it is. Okay, you have two trig functions, and they're exactly the same. One divided by the other is 1. Sine x over cos x, this is equivalent to tan x. And then if we take a quick little look, that is the right side. So we started with the left side, we turned it into the right side. Okay, so another little proof here. Okay, so we used factoring. All right, in the next example, we're going to use even a different concept. Okay, so in this one, I'll give you 1 over 1 plus cos x plus 1 over 1 minus cos x, and this is supposed to equal 2 over sine squared x. All right, again, first thing is to determine which side we want to work with. Pretty clear that the left side has more stuff. It is messier. So let's start with that side. So left side equals, and again, write down exactly what's there. So tell your reader what you are working with. All right, these are simply fractions, and we are to add them. When you add or subtract fractions, you must get a common denominator. Now, when you look at these expressions here, I know that they do look the same, but the one has a plus sign in it, the other has a minus. These are different numbers. This is like saying this is the number, let's say 3, and that's the number 2. To get the common denominator, you would go 3 times 2 and get 6. We do the same thing with this. Put brackets around them. Okay, always when you have more than one term, you must put a bracket around it. If you were just to keep these brackets off and only put the second one in a bracket, that would tell me that you only want the cos x to multiply with this. Put brackets around both. So this is our common denominator. To go from this expression to this big monstrous expression, I had to multiply by that. So you multiply your numerator by the missing piece. So it's 1 times 1 minus cos x. Put your plus sign down. Same thing here. To go from this to this mess, it's this one that's missing. So it's like a cross multiply here. Put your 1 down and multiply it by the missing piece. Expand the top. So when you expand this out, you get 1 minus cos x. The 1 through this bracket gives you plus 1 plus cos x. Again, do not ignore what's on the right side. Notice that there are no cos x's over on the right side. It's all in terms of sign. So that tells me that I don't want to keep this. This is a difference of squares. Okay, if you were to expand these two, what's in these two binomials is exactly the same. One has a plus sign, one has a minus. And what you saw when you learned this in grade 10 is that all you're left with is the product of these two terms minus the product of those. So when you do that, 1 times 1 is 1. A positive cos x times a minus cos x gives you minus cos squared x. Okay, on top, I have a minus cos x and a plus cos x. They wipe each other out. Then 1 plus 1 is 2. Again, notice over on your right side, there is no cos squared x there. It's sine squared. Well, we saw with our Pythagorean identity that 1 minus cos squared x is sine squared x. And there's our right side. Okay, so again, we've gone from the left side and we've turned it into the right side. Okay, those are the examples for this little video. I will come back with a couple of more videos that give you some harder examples and trying to use yet a few other little techniques that can help you solve these.